Implementation in the science classroom takes quite a bit of consideration. The pedagogies I will use, I'll draw upon the 5E's inquiry-based learning model. This is what we'd use throughout the semester in our tutorials, and I found it invaluable, especially the engage component at the beginning. Students can become very engaged by looking at the model, seeing the lights, the motor, the sound, everything working all at once. Then they can obviously go from there to explore how they themselves can get a globe to light and a motor to move, etc. In the explain phase, I will obviously elaborate on that and show students how to reverse the polarity of the motor, for example, to make the truck reverse rather than just moving forwards. Students can obviously look at the problems that perhaps arose when trying to wire the buzzer, because the buzzer has to be wired in a specific way to work. So for example, students may not have got the buzzer to sound if they didn't put the red wires to the positive terminal of the battery. So that will all be explained. In the elaborate phase, students can then perhaps in small groups build their own Healthy Harold truck, where they can get all of those components together working in series and parallel circuits. And the evaluate phase can be used obviously to recap student knowledge, explore any gaps in further knowledge, and used as an assessment tool. Key considerations in the science classroom are obviously WHS, so safety of students. To build my artifact, I actually learned to solder. So students wouldn't be soldering, of course, in the classroom. They could be twisting wires and perhaps putting tape to keep them together, but they will be using hot glue guns to attach the components around the circuits. Students will obviously need some protective equipment, so gloves to protect their hands and goggles for their eyes, particularly because there's a motor that could spin anything off and obviously hit a student in the eye. So protective equipment is essential. Obviously we will brief students on safety and different protocols on how to stay safe in the classroom while in the design and production component. Parent helpers could also be valuable in helping students and supervising with the hot glue gun, for instance. Other considerations would be scaffolding. So I would pair students with more and less capable peers in small groups of 4, just to provide support to students who need it during that design process when they're in that elaborate phase. Other considerations would be assessment. So students would be asked to take photos of their model as they're progressing, so during the construction process.